Hello everyone and welcome to today's third grade math video. I created a PowerPoint that I'm going to share. And the topic of today's lesson is the attributes of quadrilaterals as well as perimeter. You will need paper, a pencil, and an eraser. Okay, so first let's talk about attributes, which again are the qualities of different shapes. So our first vocabulary term is quadrilateral. And quadrilateral is a long word, so we're going to break up for its meaning. So quad means four. So here's four. And lateral is a word that means sides. So quadrilateral means four sides. So this could be a square. A square has four sides, so a square is a quadrilateral. Or it could be a rectangle, which also has four sides. Or it could be a diamond or a rhombus, which also have four sides. So some other vocabulary terms are angle, and an angle is like a type of measurement for how small or big a measurement is. There's also something known as right angles, and right angles basically have the shape of an L, a capital L. So for example, this is a right angle, looks like a capital L, or if it's rotated, this is an L, kind of like an upside down L. This is also an L or right angle. And this is also a right angle. This one and this one are the same. So there's a bunch of different things that right angles can look like. They can be rotated to look a little bit different, but will always have that L shape. So those are right angles. There's also something known as an obtuse angle, which is bigger than a right angle. A right angle would go right about here to form that capital L, but obtuse angles are even bigger. So they're bigger like that. That's an obtuse angle. This one's also an obtuse angle. We can see that it's bigger than a capital L would be. And this one is also an obtuse angle, also bigger. So you can also demonstrate angles by this. So right now I'm modeling a right angle. It looks like a capital L. So this is a right angle. This is an obtuse angle. It's bigger than a right angle. If this is a right angle, then this is an obtuse angle looking at my camera. Now there's also something else we're going to learn, which is called an acute angle, which is smaller than a right angle. So these are acute angles, smaller than that capital L. So if a capital L is right about here, then an acute angle is even smaller. Here's another acute angle, here's another one, and here's another one. So again, these are smaller than right angles. So there's another vocabulary term called parallel. So parallel lines mean that the lines never cross or touch or meet. So if you look at my camera on the upper right corner, I'm showing parallel lines. They never cross or touch or meet. These are also parallel lines going like that. So are these or these? They're all parallel lines. They never cross or touch or meet. Okay, so this one and this one are parallel. This one and this one are parallel. This one and this one are parallel, and our brown lines are parallel, and our blue lines are parallel. So think of it as railroad tracks, for example. Railroad tracks never cross or touch or meet, so they're kind of like railroad tracks. That's how you can think of parallel lines. Now there's a final vocabulary term called equal sides/angles, and this basically means that a pair of sides or angles has to be equal. So for example, our blue sides are equal in length, and the brown sides are equal in length to each other. As for angles, for example, this right angle is equal to this right angle. They both have that same measurement, so they're both right angles. So now we're going to have some practice applying our knowledge of attributes to solve for some shapes. Okay, so the directions are write down everything you know about the shape. So the first thing we're going to start off talking about is its sides. We're going to look at how many sides this rectangle has and whether or not the sides are equal. So I will guide you through this one. So let's count the number of sides. So we've got 1, 2, 3, and 4. We have 4 sides for this rectangle. Now we have to think about whether the sides are equal. Well, looking at this length, it looks like it's equal to this length, and both lengths have the same measurement of 12 centimeters. So these two sides, the ones in red, are going to be equal. But if we look at this length of 12 centimeters and the width of 5 centimeters, we can see that the length of 12 centimeters is much longer than the width of 5 centimeters. So these are unequal. They have two different measurements, 12 centimeters versus 5 centimeters, so they're unequal. Now, if we compare our width with the other width, so both of them are these purple lines, we can see that these widths have the same measurement, so they're equal to each other. So to recap, our lengths of 12 centimeters and 12 centimeters, our lengths are equal to each other, and our widths of 5 centimeters and 5 centimeters are equal to each other. So our lengths are equal and our widths are equal. So to answer the question, we have 4 sides, 1, 2, 3, 4, and the top and bottom sides, which are our lengths, are equal, and the left and right sides, which are our widths, are equal. So that's the answer for that one. Now let's talk about whether any of these lines are parallel. Remember, parallel means that they don't cross or touch or meet at all. Well, let's look at our width of 5 centimeters and our length of 12 centimeters. Well, we can see that they meet right here. And parallel lines don't meet, meaning that these two lines cannot be parallel because they do meet. Let's take a look at our purple lines, our widths, right here and right here. Well, these never touch or cross or meet, therefore they are parallel. So we have our widths that are parallel. Those are the left and right sides. Let's check the top and bottom sides to see if those are parallel. We have 12 centimeters and 12 centimeters, and we can see that these red lines will also never cross or touch or meet. So these are also parallel. So we have two sets of parallel lines. We have the top and bottom lines are parallel. Those will never cross or touch or meet. And we have the left and right sides are also parallel. Those will never cross or touch or meet either. So now it's time to talk about the angles. How many angles are there? And what kind of angles are these? Let's first look at the question that asks how many angles there are. Well, we have 1, 2, 3, and 4. We have 4 angles. Now, what kind of angles there are? So if you look at my camera on the top right side, I'm showing a right angle right now. And remember, it's kind of similar to a capital L. These are right angles. Then there's an obtuse angle, which is larger. And then there's an acute angle, which is smaller. So which angle do you think this is? Is it a right angle, an obtuse angle, or an acute angle? If you said a right angle, you are correct. It looks like a capital L. This one is also a right angle, as is this one, as is this one. So for our answer, we have 4 right angles. And then in yellow, you can see it a little bit better. These are all right angles. Okay, moving on to our next question. Do you know what type of shape this is called? It is a vocabulary term at the way beginning, and it starts with a Q. If you said quadrilateral, you are correct. Remember that quad means 4 and lateral means sides. So quadrilateral literally means 4 sides, and we have 4 sides here. 1, 2, 3, and 4. So it's a quadrilateral. And it also has another name. This one starts with an R. Do you know what name this is? If you said rectangle, you are correct. This is also a rectangle. So it's both a rectangle and a quadrilateral. Now there's another term that this also goes by, and that is a parallelogram. And a parallelogram means that it has 2 sets of parallel sides. In this case, it has its purple sides are parallel to each other, and it also has its red sides, which are also parallel to each other. So it can go by rectangle, quadrilateral, parallelogram, all of those different terms. So now let's look at our attributes for a square. So we have a square of 8 inches by 8 inches all the way around. So all of the sides are 8 inches long. So my first question to you is, how many sides do we have in our square? Well, if we count them up, we have 1, 2, 3, 4 sides for our square. And are these sides equal? If you said yes, these sides are equal, you are correct. They are all 8 inches. They're all the same length. They're all equal to each other. So we have 4 equal sides. Now let's take a look at whether these lines are parallel. Are there any sets of parallel lines in the square? If so, which ones? If you said that the top and bottom lines are parallel and the left and right ones are also parallel, you are correct. So again, these lines in red are parallel. They will never cross or touch or meet. And the left and right hand sides are also parallel. Those will never cross or touch or meet either. Let's talk about angles next. First of all, how many angles do we have? Well, if we look at our square, we have 1, 2, 3, and 4. We have 4 angles. Now, what kind of angles are these? So again, if you look at the top right corner where my camera is, I am showing a right angle right now. And here's an obtuse angle. And here is an acute angle. So do you think that this square has right angles, obtuse angles, or acute angles? If you said right angles, you are correct. There are 4 right angles in this square. 1, 2, 3, and 4. 4 right angles. Okay, now what about the type of shape? And I did say it earlier, but there's a couple of different names for this type of shape. There's 3 different names, in fact. So what are some of the names of this shape? If you said that one of the names is a square, you are correct. Squares, again, have all equal sides. All of their sides are equal. Another name for this is a parallelogram. That's because it has 2 sets of parallel sides. This side is parallel with this side, and this side is parallel with this side. They will never cross or touch or meet. Now there's one final vocabulary term for this square, and it is quadrilateral. Quadrilateral meaning 4 sides, and the square has 4 sides. So square, parallelogram, and quadrilateral are all wonderful terms for the shape. Okay, let's try one more. So now we're going to talk about the sides and angles and everything for this shape. So we can see that this shape has 5 meters for all of its sides. So my question to you is, how many sides does it have? And I will let you pause the video to write down your answer for how many sides it has. After you're done writing how many sides it has, next you'll write equal or not equal. So you'll write equal if all of the sides are equal, and you'll write not equal if the sides have different lengths. So I'll let you pause the video and write that on your paper. So next, we're going to review the answer. And the answer is that this shape has 4 equal sides. So 1, 2, 3, 4 sides. And the sides are all equal because they all have a length of 5 meters all around. So 4 equal sides. Let's move on to parallel. So my question to you is, how many sets of parallel lines are there? So for example, if you look at the camera, this is one set of parallel lines. This is another set of parallel lines, and this is another set of parallel lines. So I just showed 3 different types of sets of parallel lines. So my question to you is, how many sets of parallel lines are in this shape? So I'll let you pause the video and write down your answer. If you said that there are 2 sets of parallel lines, you are correct. We have our green lines, and then we have our red lines. So 2 sets of parallel lines or parallel sides. All right, moving on to angles. How many angles are there? And what kind of angles are they? Remember, your options are a right angle, an obtuse angle, and an acute angle. So again, how many angles are there? And what kind of angles? Right angle, obtuse angle, or acute angle? So I'll let you pause the video and write down your answer. All right, time to check our work. So this one has 4 angles, 1, 2, 3, and 4. And for what type of angles they are, well, you may have noticed that this one is smaller than a capital L. And if it's smaller, then that means it's an acute angle, a tiny angle, a cute one. So we've got an acute angle here and an acute angle here. So we have 2 acute angles. Now we also have some obtuse angles. Obtuse angles are larger than right angles. So in my camera, I'm showing a right angle, and even bigger would be an obtuse angle. These are bigger than capital L's, they're bigger than right angles, so we call them obtuse angles. So our green ones right here are both obtuse angles. So we have 2 obtuse angles. So again, 4 angles total, 2 acute angles and 2 obtuse angles. Now let's think about the type of shape and its name. So I want you to come up with at least 1 or 2 different names for this shape. So I'll let you pause the video and write down the names of the shape. So if you said that this shape is a parallelogram, you are correct. It's a parallelogram because it has 2 different sets of parallel lines. Here's our first set, and here is our second one. Now it's also a rhombus. And if you're not familiar with the term yet, that's okay. A rhombus basically means that it looks like this and all of its sides are equal. So all of these sides, for example, are 5 meters each. Now there's one final vocabulary word for this, and it's quadrilateral. Again, a quadrilateral is a 4-sided shape. We have 1, 2, 3, 4 sides, so it's a quadrilateral. Okay, so that is attributes. Now let's talk about something called perimeter. So we need to first review some vocabulary terms for perimeter. So perimeter, the first term is going to be length, which basically means in this case the long side. So here we have a length of 8 inches for this rectangle. Another vocabulary term is width, and this is our width right here. We have a width of 6 inches on both sides of this rectangle. Another word is units, and units are things like centimeters, feet, meters, inches, miles, kilometers. All of those are units. So for this problem here, our unit is going to be inches. 6 inches for our width, 8 inches for our length, so we know that inches is going to be our unit. Our last vocabulary word is perimeter, and perimeter is the outside. It's like the distance. So it's basically adding all of these outside sides of the shape. So I'm going to show you what I mean through an example. So for a rectangle, it has a length of 8 inches and another length of 8 inches here, and then a width of 6 inches here and a width of 6 inches here because these are equal lengths, equal widths. So to find the perimeter, all you have to do is add all of the sides together. So I have 8 inches. So I've got 8 inches right here. So 8 inches plus 6 inches because I have to add this side. So we've got, again, 8 inches plus 6 inches. Now we need to add this side. So plus 8 inches, that's right here, plus 6 inches. And that is right here, plus 6 inches. Okay, so to recap, perimeter means that you add the outside. So we've got 8 inches plus 6 inches plus 8 inches plus 6 inches. When you add all of those together, 8 inches plus 6 inches plus 8 inches plus 6 inches, you get 28 inches. And so the P is going to stand for perimeter. So it's saying that the perimeter equals 28 inches. Again, we got the perimeter by adding up all of the sides. Let's try another example of perimeter. So we need to find the perimeter of the rectangle and include the units. So we remember that perimeter means that we add up all of the outside edges. So we would need to add 4 feet plus 2 feet plus 4 feet plus 2 feet. And I got that 4 feet and 2 feet from the measurements that they give us for our length and our width all around. So again, we need to add 4 feet plus 2 feet plus 4 feet plus 2 feet. So what is the sum of those numbers? If you said that the sum is 12 feet, you are correct. So 2 feet plus 4 feet plus 2 feet plus 4 feet equals 12 feet. Notice that it doesn't really matter which order you add all of these together, as long as you make sure to get to all of the sides. So I could have added up 4 feet plus 2 feet plus 4 feet plus 2 feet. So I could have started with my 4 feet, or I would have gotten the same answer by starting with my 2. So I could have done 2 feet plus 4 feet plus 2 feet plus 4 feet and still gotten that same answer of 12. So P for perimeter, P equals 12 feet. The perimeter of our rectangle, adding up all of those outside edges, the perimeter equals 12 feet. Let's try one last example of perimeter. So let's find the perimeter of this door, including the units. So remember that our units are feet. Okay, so the perimeter means that we have to add up the outside. So all of these sides, we have to add them up. So I'm going to start with 3 feet. So I would add 3 feet plus 7 feet plus 3 feet plus 7 feet. And what is the sum of all of those numbers? Can you work it on your paper and tell me the answer? So if you came up with the answer of 20 feet, you are correct. Again, perimeter means that we're finding the outside measurement, the outside distance of the shape. So in this case, we have a door, which is 3 feet by 7 feet. And so we added 3 feet plus 7 feet plus 3 feet plus 7 feet, which equals 20 feet. Awesome job. So I hope that you enjoyed today's lesson about the attributes of quadrilaterals, as well as learning about perimeter and applying your knowledge through some examples. I hope you enjoyed this lesson, and I will see you back soon for a new one.